can frankly say I wouldn't be here had it not been for Eleanor and all the help she's done over the years for me personally, for both Olivia and I, particularly for Flashline, or the return to Flashline, which was last year's mission. Many people don't know it was vacant for 6 years, and because of its vacancy, it had experienced quite a bit of deterioration. And ours mission last year was just to get there and fix it. So here we are. Devon Island is also called Taluruti. Taluruti is you might have seen some of the details earlier yesterday that Bill had provided. You can see that it's very realistic to Mars, at least with respect to how hummocky it is. You can see that because it's right on the edge of a crater, all of that has slothed over the edge of the crater, and this is just really ejecta that is formed. And to me, I was astonished at the similarity of the two images. So kind of going along the same theme. And the environment itself is more than extreme. We'll talk about that here in a minute. And then lastly, I'd probably want to just have Olivia kind of run through all the science and some of the extremophiles and things. The objective last year was to show up. We didn't know what to expect. We had no clue. And we weren't sure if Polly, no relation to Eleanor, hadn't shown up and torn the place up on the inside. So, which was, by the way, Eleanor, if you remember, was one of the first things you had mentioned when we first talked in 2020 about going back. And talk about desolate and isolated. You just can't believe it when you get there. How there's no sign of humanity other than this station and Houghton Mars project, which is just about a kilometer away. The leveraging its desolate location, it takes forever to get there. We'll talk about that here in a second. And I think with the research that we can perform there, I think it's with the right materials and maybe the right equipment, right environment, safety first, not science, then we can get a lot of really impressive science done there. The teams, as it goes, the teams themselves are picked by the Mars Society. Last year, this year, I picked the teams. Last year, we were hand selected by James Burke and Shannon, Dr. Rupert. We really did know the minute we were there, this was going to be something unique, special. We had Olivia as a seasoned scientist, I like to call you a radiation scientist, sorry. And of course, we had the crew leader, which was a geologist, and then those two engineers on the right, who were quite busy, frankly. Crew 16, that's this year. We did something different. We named ourselves. I don't know, did we have a name last 2015? I don't think.
We called ourselves the crew that broke the mold.
Oh, I have that in here. I do. I have a little image. You'll see that in a minute because of the mold situation on the inside. It was spectacular. Like you could literally peel it off the walls. This is this year's mission. Interesting dynamic that showed up in this mission that I didn't expect is that two of those people, of those 7, are couples. They're hang out and they live together, and they also live together on station. Now I said no, and they had to leave. One had to be on the other floor, and I even made it separate like that too. But that was a very interesting dynamic. So that's something that should be discussed. But anyway, let's see. Flyover. Yeah. So Mars Society owns the station. It's out on Nunavut territory. And then Nunavut territory was taken over recently by the Nunavut government. Canadians said, it's all yours. You can have it back. Nunavut are like, hey, wait a minute. We don't know what we're doing. You're going to have to stick around for a decade and help us. So they're going to help on the transition. In the meantime, there's some things about this place that Bill can attest to as well. For the 3 of us here, it's austere is probably the best definition I heard when Caleb mentioned that early on in the mission last year. It really allows for relying on each other heavily. And when I say that, I mean you really become your only source of either emotional support or physical help or just task-oriented. Sorry, I almost cursed. Task-oriented things. You're really handing each other a lot of what you have on the inside and of course the physical side of it. With respect to planetary science, it's right on the edge of a crater. It's a 30+ million year crater. I hear different numbers. I hear 23, I hear 26, I hear 30, 36. I'm just going to go in the middle. It's 30 million years, and there's not a plant to be seen unless you know what to look for and where to look for those plants. And you can read all that all you want, but the one thing I wanted to take away from it, it's so quiet there, and Bill probably can also mention this, or he did maybe. You're sitting on the crater and you can hear your heartbeat in your ears. It's that quiet. And I've never been anywhere. There's no planes, there's no flyovers, there's no sirens, nothing like that. But yeah, so spectacular. And here we are. You can kind of see I red circled the island itself. We're 680 miles south and east of the North Pole. North Pole is just up above you there. Again, kind of a closer in look at the archipelago, the Arctic archipelago. Say that 10 times fast. We're a long way away from home. That's my home, San Francisco. 5 times is not the right number. It's 9 times the size of the Big Island. It's pretty heavily populated. You got to watch out. The traffic is awful there. And and last year it wasn't that cold. There was cold days here and there, but this year was just ridiculous cold, and winds were unbelievable. You just live with it. You know what you're getting into when you go. Here we're right at the corner of the shoe boot. I don't know what that is, but that's what it looks like to me. And then we get a little closer to the crater. There's HMP right there. I think that's them. Isn't that what that says? Houghton.
Impact crater.
Just impact crater. I think we're up to the north and west of that, right? Yeah. And you can kind of see it's a nice little scar. I imagine it was a bad day on the planet when that asteroid struck or whatever it was. What happened there? Why did it go back that way? Was that the extra one? Houghton crater, asteroid or comet strike as a meteor, plus or minus 30 million. Very big. You can't see to the other side, even though this is a 180-degree view, looking straight across. You can't even tell what's on the other side there. No idea. And that's Olivia on the phone with her mom.
Oh, really?
And upper left there. And so spectacular. And this is where I was sitting. I was like, is that my heart rate? Anyway. Again, kind of another little view of it. Beautiful. This is Jake. Well, I called him Redbeard. He flies a little plane called Moses. And that was quite the experience, landing on that. 2 ATRs to get there, 2 Twin Otters. We landed in the weirdest places I've ever landed in an airplane. And and then it was 2 more flights for the team and all the gear to get there. We took almost 2,000 kilo. I think it was a little more than that, actually, if you add us and all of our gear. These 3 were the laughing stock of the crew. And then Caleb was sarcastic humor, so that was brilliant. Lots of logos here. You can kind of see Discovery's been around for a while. And you'll love it if you come and visit. History. 99. So it was designed in 99, built in Monterey, California, pieces of it, and then up in the northwest near Seattle. And then flown or train or boat pieces over to Resolute, and then Resolute to Houghton. Now, Houghton was interesting because they used C-130s to drop all the equipment down and parachutes and da-da-da-da. And one of the most important things was the crane. Parachute didn't deploy, and it partially deployed, but it got stuck on the 130, the C-130, and it almost brought the plane down. And so to this day, when we hear that story, you think, wow, that was close. HMP is literally around the corner, so you can't see HMP. He purposely, I think, hid, but there's a little escarpment up in the upper left there, and he is literally just around that. As extreme as it is, it's spectacular. Then engineers fixed everything, you name it. Didn't matter what it was, they'd fix it. Now, it might break the next day or a few days later, but that was a function of that environment it's hellish. And yeah, we had all kinds of crazy stuff happening every day. It was quite busy. Which one is this? Oh, yeah. So we were outside in tents for 6 days. Literally, thankfully, someone brought us who was that got us a bear fence? Eleanor, right? Eleanor got us a bear fence. So we had a bear fence protecting us in case any bears or anything else showed up, mostly bears. But because I had been in the climbing business previously as a guide, it was offhand for me. It was just so remote. It was quite scary. We did a bunch of electrical upgrades last year and this year. You can kind of get a sense of the galley. That's the galley. I didn't want to show you the inside because it's going to change. We'll just say, yeah, it's going to change one day. We did have far right. That's Cam Smith's. That's one of the Smith suits right there. That's Mason. If anybody knows Mason, he was with us. This is Red, friend of mine. That's me underneath the sink, fixing a new sink. We had the second sink in a year we had to put in, and yeah, so we're moving on. This is Olivia and I. This is how we had to dress, full PPE, to go upstairs. The mold was so incredibly healthy. I don't know what else to say about the mold. These are some of the things, and this kind of leads into what Olivia is going to speak about, but that's an extremophile. That is called the woolly bear moth. Woolly bear moth is a 7-year life cycle. It has to go into stasis, and its heart stops. It dies, technically, and every year it comes back, and it has to do that 7 times, and in the 7th year it turns into a moth. If that gets disrupted at all, then sayonara. This is a plant that grows pretty regularly around there, and that's from just me getting down really low and looking at it, and it kind of looks like a little forest. It's so cool. And that's Polly there in the middle, and yeah, so that's it. And then Livs is going to take over. And that's Olivia.
Yeah, that's a photo of me on one of our EVAs. So thank you, Terry.
Yes, of course.
So as mentioned, in 2023 on Fmars Crew 15, I was the Chief Science Officer for our 5-person crew. And our mission had 2 objectives. Primarily, we were to return to the station after a 6-year hiatus and restore any systems that needed fixing and do a lot of cleaning. And then once we thought we got the station up to a habitable and usable point, we then started our simulation. So this ended up being 1 week of repair and restore, and then a 1-week analog simulation, in which we were able to conduct full scientific plan and extravehicular activity. So this was the 4 main experiment ideas behind the science mission. So firstly, geology. So our commander, Andrew, is a geologist. And the last time that a mission had been conducted at Fmars was the Mars 160 in 2017, in which they conducted a geological and biological experiment plan in both Fmars and in MDRS. So we wanted to be able to continue on that path and return to some of the sites located during the Mars 160 mission, and also locate other geological points of interest. For the microbiology, we were very interested in algae and cyanobacteria, locating any bacterial colonies that we could find in the area. And also we were interested in investigating macroinvertebrates. We ended up only finding 1, but that was on our inventory. Thirdly, environment. So I'm an environmental health scientist, and given the unique location we were in, we wanted to use the opportunity of being on Devon to really look at the environment from a health and safety point of view, and also investigate the impact that climate change is having on the local environment. And then fourthly, we had human factors research, looking at the psychology of the crew during our mission. Even though it was only a 1-week simulation and a small person crew, we were able to conduct some interesting studies during our time there. So from the geology, Andrew led the EVAs looking for certain points of interest. So on the top left, we stumbled across this fossilized worm burrow on one of our EVAs. Also, because the impact crater is in a site that was underwater millions of years ago, you can find all around the area these fossilized coral that have been located and kept there by various crews. We were also able to locate a stromatolite, which was one of the items we were looking at, which is fossilized cyanobacteria from also millions of years ago. And Paul Knightley, who was the crew geologist on Mars 160, he had sent us these data loggers to install in the crater. And this will be kept at the site for a period of, it's still there, so it's going to spend at least 2 years installed in the crater, and is measuring permafrost depth over the course of the winter and summer. And so I think some interesting data has already been collected, but we'll return and collect it next summer when it's returned. This was a piece of rock in the middle that was found by Andrew, which was impact breccia from the initial impact of the crater. And when he brought it out, it had this orange exterior and then very white interior. And so we kept thinking that it was a loaf of stale bread, hence the label. And then I love this video that we took. So I had a GoPro that we brought with us, which was a hydrothermal chimney that Andrew located on one of the EVAs. And he took this 360 video of it. So I always like watching that. And then this is another image of the stromatolites, estimated to be around 23 million years old. And then walkie-talkie for size. And I believe the crew this summer with Terry returned to the site of the stromatolites and collected some more measurements on, and also were able to locate even more stromatolites. Then from the microbiology, we found a couple of algal mats on our EVAs, and were able to take samples back to the lab and image under the microscope. And also these sites were geotagged and returned during the 2024 mission, as well as locating some other algal mats. So these will be studied. And also on the top left is the macroinvertebrate. That's a mosquito larva that we found rampant, and there were a lot of live mosquitoes as well, one of the very few living organisms in the area.
Remember the one that you got in your helmet?
Yeah, and actually talking about bugs in the helmet, yeah, a mosquito got into the helmet on one of the EVAs, and we weren't allowed to break sim to take the helmet off, so it was quite a challenge. Luckily, I think I managed to get it before it bit me, but something to think about in spacesuit design. I think the closed system would have been better. And then from the environmental science point of view, so I wanted to assess water quality, mainly because our source of drinking water was the creek in the nearby area. So we wanted to firstly check that it was safe to drink in advance, and then also air quality and radiation, because my PhD research is in radiation effects on the brain for astronauts. So I was curious as to whether or not we would see changes in the radiation dose at this location. As Terry mentioned, there are very few signs of flora in the area, but there are a few very resilient species that we could find. In particular, this Arctic poppy was quite prominent. And also, we didn't see any, but there was evidence of lemmings that were in the area, including one crew which had found bones from a lemming and made an art piece from it and displayed it inside the habitat, which was quite morbid to find on the first day. And then this plant is the staple food of the lemming. So in terms of water quality, so I had brought some of these test strips to look for contaminants, and luckily no contaminants were found. And then we also conducted bacterial coliform tests. This is an image of Caleb collecting some of the water samples, and this was the creek that we would collect all of our drinking water and usable water during the missions. Also, Terry and I have been collaborating on a microplastics and nanoplastics study. So, as many of you may know, microplastics have been detected in some of even the most remotest parts of the world, including many parts of the Arctic and in Antarctica. And so we wanted to make use of being in this incredibly remote, isolated environment to see if we could detect microplastics here. So we collected water samples from the creek, from the lakes, as well as some snow melt and ice where we could. And we conducted a sort of preliminary methodology test of the microplastic detection using a Nile red dye in the lab, but then also have returned a lot of the water samples back to California, where we will analyze them further. And I've also been able to collect some water samples from these sites around MDRS so that we can conduct a comparison and identification of microplastics if they are in the area. We did find some plastic waste. I'm not sure where the origin of that was in one of the rivers, which could have been like washed down by any point. It could have been from previous crews or trapped in permafrost for years. We don't know. So there is a strong possibility that plastics are present even here. And then this is an example of some of the ice samples that we were collecting on one of the later days. And then for air quality, so we brought mold tests so that we could make sure that it was safe to return into the habitat. We were, as the images show, we were wearing respirators on the early days before we could clean all the mold, and there was a lot of mold. But luckily no black mold, and we got to the point where we didn't think it posed a significant risk. And then we also brought air quality meter. So these are a couple of images that we took on the flight over. And this was during last summer, where there were hundreds of wildfires occurring in Canada at that time, and we could see many of these small spots as we were flying in. And this photo of the sun down here was in the middle of the day in Yellowknife, when we had first arrived for the mission. And actually on the way back from Yellowknife, not long after we left, there was a wildfire in that area and the entire city had to be evacuated. So I was curious if we could bring an air quality meter, in particular that measured particulate matter levels, to be able to see what the air quality was like in the places that we went. But actually, we ended up using it more to control our own indoor air quality. So we found that between the two levels, there started to be a significant temperature difference. So this is a floor plan of the lower and the upper level of Fmars, which led to a lack of proper air ventilation between the two levels, and this caused our carbon dioxide levels to spike, as well as evidence of VOCs like formaldehyde and benzene. So once we noticed this, we quickly installed a ventilation system and were able to reduce these down to safe levels. But we wouldn't have thought to bring something like this if it weren't for our interest in outdoor air quality. So something to suggest as well is bringing tests, and particularly looking at things like VOCs and particulate matter, in particular around kitchen areas that could pose a health risk for analog astronauts. And then for the radiation, so for our year, I brought a few passive dosimeters, known as TLDs, or thermoluminar dosimeters, and these collect a cumulative dose. So I left one in my home in Southern California, and then brought the other two with me to the other three with me to the Arctic, and then installed them on one of the first days at different points around the habitat, both inside and outside. And then I returned them back and shipped them back to the company and got a reading on the dose. And what surprised me was actually how much more significant the Arctic readings gave, about 15 times higher dose. This is not a dangerous level. This is sort of comparable to the annual dose that you receive from food, because everything has a very slight radioactivity to it. But something to keep in mind, and we were unsure if this was due to radon, which has become more of a concern with climate change as permafrost is thawing and leading to release of radon in particular in the Arctic. Could be due to the elevated cosmic background levels given our proximity to the magnetic North Pole, or also could be due to radioactive, naturally occurring minerals in the area around. And actually, on the second year, Terry's crew brought an active dosimeter that he wore on several of the EVAs, and they found this hotspot in one of the locations, which is yet to be identified, but is likely due to a naturally radioactive mineral. And then from the psychology, so we conducted 2 studies in collaboration actually with the AARG, which you've heard about this morning. One of them was in collaboration with Scott Van Hoy, which was a motion recognition study, where we also had the images of the different expressions, and periodically throughout the mission, we were trying to identify which emotion was associated with each expression. And we also filled out a very long questionnaire, which was looking at markers of stress, depression, loneliness, and motivation. And then the second study was in collaboration with Lex, who's also here, in which we were wearing a wearable monitor from Garmin and measuring our heart rate variability as a marker of stress, both before, during, and after the mission. And during the simulation, we also were conducting focused breathing sessions, similar to a meditation, where we had an audio guide and the whole crew would meet and conduct the focused breathing. And so we were particularly interested in if those sessions were able to reduce our stress in a measurable way on the Garmin monitors. So these are the results from the questionnaire that we did with Scott Van Hoy. And so each of these colored lines represents one of the crew members. And then we conducted the questionnaire pre-arrival, twice post-arrival in sim, and post-departure and then home. So you can see a lot of these are relatively stable with some peaks, in particular in stress and irritability and depression in the middle of the mission. Also a slight drop in empathy at a certain point, which was assessed using a series of targeted questions about sort of your relationship with the crew and your sort of personal self-assessment of how you were feeling on that day. And but also changes in motivation, and yes, and then also for this is a plot of the accuracy with the emotion recognition task, I think. So we had some missing data on that one, so weren't able to generate a significant result. But what was most interesting was that loneliness was negatively correlated with stress. Possibly because we were very active because of all the work that we had to do. So we think that this was able to counteract some of the isolation and loneliness feelings by being so preoccupied. Also that recreational risk-taking was negatively correlated with the accuracy in the facial recognition test, but positively correlated with incorrectly choosing sad faces. So there were some very interesting results on that, and I think more will come out given that this study has been repeated in Terry's mission and also has been conducted at several other Analogue facilities. And then for the Garmin study, so I extracted just my data for this. So this is the stress level calculated through heart rate variability, both before, during the mission or at Fmars and afterwards. And you can see there are a couple of spikes in the stress. And I was looking back on the schedule and I found that, well, the spike that was the highest correlated with the day in which we had the longest EVA. Terry, Andrew, and I were out on EVA, and we were trying to locate the Horton River. However, we got to a point in the creek where the sides or the beds of the river were so steep that we couldn't drive the ATVs across the terrain at all, and we couldn't drive it across the river either. So instead, we had to leave the ATVs behind, bring all of our stuff, and walk as far as we could. And this was, in the end, even though it was in the Arctic, it was getting very hot. We were out for, I think, 5-6 hours in the heat, no water, and trying to find this river point. And while we collected some really interesting points of interest, we were not able to get to the river, and I had to make the decision to turn around. So I think that's likely a contributing factor to the high stress of that day. And then on the right is a plot of my stress before and after focused breathing. So the stress level was measured every 3 minutes. And while there weren't enough data points, it's not a significant difference. You can see quite a strong change in the stress before and after. So at least for me, I think it showed that the focused breathing was pretty effective at causing a sort of instantaneous reduction in stress. So yeah, that was the science mission from our year, which was then continued and built upon by Terry's crew this year. And then I think there are plans to conduct similar research in the future and make use of the environment that Fmars is located.
Yeah, it's it's interesting. We have to continue on that research path. One of the requirements of the Nunavut Arctic College and the Institute, Nunavut Arctic Institute, are that they see meaningful results for themselves. Environmental was probably the biggest, I'd say, Olivia, that they were really focused on, which I get. And of course, we were there for the station. The station, not in disarray. Well, yeah, needs a lot of work. So someone asked me if it's safe, and I went, well, no, not safe. Now, it is safe, right? When you're inside, you're safe. But if anything happens outside, you trip, you fall, you hit your head. We really only have sometimes hours in those injuries, sometimes less, right? And, we were, the team was a bit surprised to hear that I needed to know who they wanted me to call and what they wanted me to say if anything happened really, really bad. And then, of course, it's called a black letter. I don't know if you ever heard that. So we made everybody write a black letter on mission 2. Well, now mission 16, crew 16. But I have to say, Olivia, kudos to you, because we went no idea what we were doing on the science, none. And Olivia built methods for most of the experiments, and then her follow-up to the Nunavut Arctic College and the Institute were spectacular. And they were like, we want more of this. And so we're back now, and we did it again this year, and we really just built on your work. And to this day, happy I met you too. Anyway, let's do the last slide. And this one is the movie, right?
Is it?
Oh, is this the last one? Oh, the station remains. There's another one after this. Come see me if you want any questions about Fmars. We're trying to change the name. This is the movie. Oh, this is good. You got to see this. I don't know if you'll hear it. No, you can't hear it.
No, there's no audio.
But here comes Jake. Where is he? There he is. He did a flyover as he was leaving. And of course, we're all going, whoa, see you later. And there he goes, done. So thanks to Dr. Zubrin. He's always been very supportive of me. And they recently announced that I'm now the director for the station, which I didn't expect that would happen, but I'll help. And then, of course, James has been amazing. Eleanor early on. Actually, she and I'm not kidding you, had this entire conversation in 2020, and then that just continued. Because initially, I think we were planning on going. And Roger got a Starlink initially. Sam's been great with engineering. And of course, Bill knew the station or knew the area very well, so that kind of made it easy for me to commit to it. And once you go, you likely will want to go back. And there's something magical, in my opinion. It's always science first. Yeah.
It's not a
Science.
holiday.
Yeah.
Yeah, it's safety first.
Safety is a given. Some people don't know how to spell it. Walk around America. Anyway, so that's it. Questions, comments, thoughts?
Thank you for your time.
Thank you. This one here.
All right. Hi, I'm Florian. We chatted
Yeah.
yesterday really quick. I already had like a non-verbal discussion with Elo, like how many questions I would be allowed to
We'll
pass.
just pass it around. We've got time. That's why I wanted to go fast, and then the lads left.
I'm doing just one, right? So you haven't left the radio code next to this radiation thing you found, so there's no spectra yet of what there is that might radiate, right?
So I told you the story. There is a spectrograph now that's available as the new software upgrade, and you can get down to what the various particles are. And I haven't deciphered that data yet, but my guess is kind of what you'd said and what Olivia had surmised as well, is either radon or local environment. And local environment there means, right, granite or something like that.
Yeah, sure. Because I come from like a fairly radioactive area in Austria,
Yeah.
where there's a lot of granite, a lot of radon, and so actually it's in the building codes where I'm from to install active ventilation if you have like a basement, because otherwise people will die from lung cancer.
Yeah.
It's really tough. My actual question is like out of the lack of situational awareness for the mission planners during our last mission, I kind of implemented like an in situ 360 georeferenced auto-rectified mapping endeavor of like not so much for actual areas of interest, but like for the entire region. So I was able to kind of map out all the access roads and send the mission planners like these photographs that they may or may not use, but it's like.
Yeah.
And also use the drone to kind of do some really rough, really preliminary photogrammetry reconstructions of the area. So is there something that you're interested in or that you've potentially already done?
Yeah.
And the sites?
No, in fact, this year was the first year we brought anything that would give us some type of surveillance. So it's very difficult to drive down into the crater. I think you've been pretty close to the center of the crater.
That's right.
Yeah. So we walked, and it was almost an 8-hour event. And of course, I'm worried that someone's going to either die or trip or fall, and then I'm going to go, well, now what? And pick them up, carry them back, or call for help and hope for help. But so I was, quite stressed that entire time. I'd love to see my stress numbers if I had an HRV watch on. I bet they were way.
Yeah, but so let's chat later, because that's exactly what we did.
We brought it this year, though, and that was the only time we've ever had kind of an aerial situation awareness. And we did take that drone all the way to the center. And it was a DJI, not DJI. Well, it might have been a DJI, but it was one that can go forever and ever. And it was.
But you haven't done a systematic photogrammetric mapping of the entire site, like giving you like an elevation model and stuff like that.
No, I'd love that.
Ground-based 360
Please,
stuff, yeah.
that would
So
be
let's
awesome.
chat later, because this would be like a
Yeah.
really interesting thing, because if it's that remote and so tough to get to, it would actually pay off to kind of do a mapping of the area.
I would use that for one thing only right now, besides situation awareness. I would use that to start planning. We want to put a small radio array up there, maybe a 5-dish radio array, small arrays themselves too, only a meter and a half. It doesn't need to be huge. It is so quiet there. You could definitely do some radio astronomy there. Now, you might get polluted with solar activity right now, but you can move it around. And so we're planning on it. I need to raise the money for that. Olivia, can you help me with that?
Okay, yeah. So thanks.
I had a quick question for you, Terry. What's up next for improvements to the habitat?
Sam, what's up next? What are we working on?
In short, making it safe to operate. Essentially, the criteria I'm designing against is being able to operate inside the hab only in the event of an injury, so not being able to leave the building for 2 weeks in case of an emergency. That's the primary goal. And then also overall habitability upgrades, but the main systems upgrade is being able to do a lock-in, as it were, potentially with the vision towards overwinter, but that's a long road to make that safe.
I think we had chatted yesterday, was it something about the power systems, restroom facilities in there? Were you looking
The
at
whole
changing
thing
those?
is the whole ramshackle, shall we say?
It needs work.
It needs
Okay.
work.
Okay.
Yeah, we finally upgraded the bathroom enough so that Olivia, I'm not going to get into the weeds here, but it was pretty disgusting what Olivia had to do to go to the bathroom. And then the girls were like, well, we're not going to do that. And I'm like, no, we're not. We're going to fix that. And we did. We put a sit-down urinal in. So, I mean, I felt like that was a home run. Just getting, and it broke. We still got it there, and it still broke. Part of it broke. And we're like, come on.
And in the power system, wasn't there a problem with the power
is
system?
currently entirely diesel generators, diesel and
Yeah,
petrol.
diesel
generators.
or
Diesel,
gas.
yeah,
Yeah,
petrol,
and of course we do have 2 really big Anchor 1800 watt batteries.
Yes.
But-
So historically, it's been entirely generator powered and fairly small generators. So they need to be refueled every 8 hours
or sooner.
or sooner.
Yeah.
Which requires someone to be defueling and someone on polar bear watch, which isn't ideal. So the goal is to upgrade that with remote start, bigger fuel tanks, and have some kind of non-power consuming backup, whether that's wind or solar. And at the same time, upgrading the heating system, because heating is a major power draw, especially over winter. So if we can
And no heating there at all.
So
right
if we can either have heat recovery from generator exhaust or solar heating or something to allow it to do HVAC heating without needing to draw a huge amount of electrical power all winter, that would be...
So, give you a quick example, and then I'm going to take your question. It was minus, I don't know, minus 10. Felt like minus 40. And I had a minus 40 bag in my room upstairs, and I was cold. And so that was like the first few days of not simulation as we arrived. And when Olivia and I went last year with the team, I mean, there were times when it was 13, was it 12, 10, 10 to as 10C, approximately.
I mean, I think it was close to freezing.
Yeah, when we first got there. And then we had a hot day or 2.
Yeah, but inside the Habbo, it was like 17, 18.
Yeah.
Yeah.
To emphasize from an engineering point of view, the walls are 8-inch thick honeycomb fiberglass, so it shouldn't be cold in there. But it's
no, there's holes everywhere.
Yeah,
anyway,
exactly.
Go ahead, sorry.
No worries.
Yeah.
Great presentation and congratulations on becoming the director of the station.
Thank you.
No pressure, but I have a question about the future as a director. So imagine you have all of the needed money to make things happen over there. And my question is, what would you do actually? What would be your first steps? And I'm thinking here about also all of the research stations that we already have available in Antarctic, right? Would you consider this kind of model to, let's say, replicate that on the other side of the globe?
Maybe, yeah. You know, what's beautiful about the Arctic is it's also a dry, it's a dry cold. You've heard people say it's a dry heat. It's a dry cold, and even though there was quite a bit of snow on the ground this year when we got there, by the time we left, it was diminishing so much so that I was like, oh, okay, we're back to normal. But it's so dry up there. I think that's a bit more realistic to kind of Mars on Earth, right? Robert and Dr. Lee, don't agree on who came up with that, Mars on Earth. Nonetheless, it's perfectly set, I think, for the location. So I would consider it, but we need a big number to make it pretty, and I want to put stainless steel in. I'd like to. It's listing because of permafrost thaw, which we all are experiencing, unfortunately, which is also radon gas and some of the other things that are happening. But yeah, Olivia, we noticed that list right away, and I think I was. And of course, I told Sam it's listing, and he was like, "It's going to collapse," and it's a possibility, right? I mean, I can't say no, and so we need to fix that first. So next year, listing. That's the first 3 to 5 days. We're going to work on that. Then we've got an engineering team come in, and that team is going to just do what we can to engineer. We're probably going to bring a few stainless steel tables and maybe remove a few things, throw them out, burn them, or take them home with us. I prefer that we take them home and not run that incinerator, but there is an incinerator on the site if you want to burn whatever you want. It's a blast, and literally can be a blast, and Caleb got to experience that firsthand. Firsthand third-degree burn, and then some second-degree burns. But he's perfectly fine. So if anybody's worried about him, he's doing quite well. So anyway, yeah. Yes, sir.
So my question is to both of you.
Yeah.
So I saw a lot of results. I mean, also slides on human brain research. I mean, on that. I mean, I'm myself doing research in human brain. So I'm doing that in Germany after finishing my PhD here in ETH. My question is inspired from something that Professor Davidson at University of Wisconsin-Madison was asked once. Someone asked him once that you're using the tools of modern neuroscience to study depression, anxiety, fear, and why don't you use the same tools to study kindness and compassion? So he said it's very hard, but then that probably inspired his future research. So my question is to how would you measure kindness or compassion in an astronaut?
No, that's an excellent question. And there were certain metrics in the questionnaire that were interpreted, like empathy and kindness and the relationships between the crew. But those are very difficult to assess. And based on questionnaires, they can only take you so far. It relies on our own ability to kind of self-assess. And that could also be impacted by isolation and the experiences that we're having. So I think it is a significant challenge. It's a lot easier to recognize when you feel negative emotions rather than positive, I think. You're sort of used to a baseline positive emotions. And I think I liked the way that this questionnaire was set up. It was 160 questions odd. It was very long. And so some of these metrics were asked through a series of questions phrased in very slightly different ways. So that way it kind of reduces the risk of you incorrectly answering one or skipping one by accident, but also could sort of probe that question from different perspectives. So I think from a questionnaire point of view, that's a good idea to emphasize that. But and in terms of kindness, maybe that's something that people could assess in each other, and then you could use your other crew members as a way to kind of get some kind of average perspective on one crew member's mental state and vice versa, sort of make use of a greater sample size. But no, I think it's a really interesting question and definitely important for space missions because we want to find ways to encourage this behavior and to make this more common, as well as trying to mitigate some of the negative emotions that can get triggered. Yeah.
Thank you very much.
You know what I want? I want on the next mission, I want a clown. Just someone always dressed like a clown.
Be careful what you ask for.
A clown?
A clown.
Yes, sir. Alexis. Loja.
Thank you, by the way, for the visualization of my research. I appreciate it. Are you soliciting for next year?
We are.
And can we repeat my experiment?
We can.
We will talk about it. Thank you.
Okay.
Copy that.
I got another one. Nobody shepherded the mic, so now it's mine again. Now, just to reply to that.
No, there's a stranger in the back. He's got a question.
Just to reply to that question, I think there's a really good case for having a permanent base in one of the dry Arctic deserts, because as far as I know, there's no analog site right at the moment that we can kind of access like that. And having been to a couple of the deserts, a couple of the analogs, like once temperature drops below dew point at night, then everything becomes really moist and really humid, and it doesn't feel like Mars at all. So I think that's a really good point of having one of those stations operational and kind of in the right mindset to accept analogs. Yeah. And then another really just easy engineering question, have you thought about just putting filters in the station that you would switch on before you would accept the crew to kind of flush the air and make everything kind of like HEPA filters, like high volume stuff, to just
Actually, not considered the station off mode with the design yet. That's a good point. Thank you.
So you kind of remotely can kind of bring it up and kind of heat it, filter the air, get everything kind of up and ready before the crew actually would arrive.
The current design stack includes some non-fueled power source, whether that's solar or wind. That's up for debate. And I think having an emergency or non-habitation mode with some systems running to prevent, if nothing else, having a water heater so the water doesn't ice up is an essential feature to control that. So it does need more thought, and that's a good shout, yes.
Oh, that was another thing. I told you, the water heater blew up, and now we don't have a water heater. So we have a little thing that makes hot water, and that's it. But
did you use the kettle?
We had to use the kettle for hot water. Yeah.
Oh, I'm glad you brought it then, because
Well, I did get this year. I bought a 30 amp generator, which we need.
Yeah.
We need much more than that, but we bought a 30 amp, and that helped kind of keep things from tripping. Because every time we cooked, we were tripping something.
yeah, we could only operate one of
Can
the
you hear me now?
hot plates at a time.
And also there's like this amateur radio packaging system that's like super low power, super low bandwidth, long range, long wave datacom links and stuff like that. That could be up and running by like tiny power sources and just send like a heartbeat or like
What's
some
the
basic
sat link?
Iridium.
What-
Iridium is the alternative.
Yeah, exactly.
I'd love to have that.
it's
I'd
like
love
really
to be able
cheap.
to do that.
Iridium's a 10 watts, I think, for a trickle. So it's really low power.
That's
but
really low.
But also very low data rates. You're talking bits per second. But if you're reporting temperature and pressure once a day, you don't
Exactly.
need that.
Just
See,
like a heartbeat from the
the real
station.
issue, it's
Yeah.
vacant for 11 and a half months, 11 months. There's nobody there. So solar, we were thinking solar around the outside. The other thing, no stargazing there in the summer, unless, I don't know, you see stars and you hit your head. But the sun literally is at 20 degree or higher all the way around all day. So talk about circadian offset. That's the real deal there. Even though those rooms, which were quite dark, right? I think are state rooms.
Oh yeah, and towards the end, because of the continuous sun, we thought we'd experiment with trying to control our circadian rhythms by blocking out all the windows on the top level and using artificial lights during the day.
Yeah, it worked. When we put the lights in, right? Those other lights were awful.
Yeah, we had to. That's what we're doing. And
We got there and you're like, what happened? They were living in the 90s, in the 2000s, and you're like, guys, we've snapped out of it, right?
See, Bill, this is why when you ask what the station's like, I say ramshackle. Overall.
Yeah. Listen, it's a scary place. It can be quite dangerous. We experienced that last year, and we were lucky. We had a weather window, and otherwise we were going to have a severely injured, burned person who needs constant bandage changes for days and days and days, and we wouldn't have been able to do that. So we had to call the mission. This year, perfectly fine. Nothing crazy other than, regular madness. Nothing really. It brings out the best. I think one thing I have to say, everybody says, "Oh, you got to be an astronaut to go to space," and I don't think so anymore. We had a business person on the mission, and this guy was just a business guy, right? And he did everything. It was amazing what he did. I couldn't believe how productive he was, how kind and gentle to the other team members, and how they gravitated towards him. His name's Rhett, and he was just one of those things. Andy is very much like that too, by the way. Andy on the left. Caleb has just got a great smile, and then he just gets to work. But that's the other thing, right? There's so much work to do. I don't want to overemphasize. It's every day. So I bet we were, what do you think, Livs? Were we 30% a day on just hab maintenance? Maybe more.
It depended on the first or the second half.
Yeah,
the first half was like
100%.
100%. But yeah, because the engineers still working on the hab during the simulation, limited by the fact that we were in sim and weren't allowed to go outside without spacesuits and all that.
Right.
But they were able to keep it going, yeah.
Yeah, so you have to take it from me. No, but actually, again, like from now this ghost support crew perspective, the people you want to have in the field are not necessarily the ones that have the highest academic career, but you want to have the guys who do the plumbing, the guys who won't kind of worry to get like the hands dirty by kind of fixing the stuck toilet or anything, or like someone who knows like big learning, someone who knows to do like proper electricity, like a proper electrician, like a certified electrician. Have that someone on your team, like someone who's certified to know how to wire a fuse box and stuff like that, and also like get a core team of qualified workers that you can kind of just slap a task on, and by the evening or by the next day, they're gonna have it figured out. They're gonna have built the ramp, they're gonna have built the structure, they're gonna have wired everything, and it's gonna be up and running the next day. And these guys and girls are usually the ones that keep the entire thing going. And so, like, seeing what you guys been doing, it's mostly like that. When you guys are plumbers, electricians, structural workers, construction workers.
I'd rather be the plumber on that mission, or I'd rather be the electrician.
And it kind of also circles back to what Christiana was talking yesterday. It's like, and when people work,
you guys are lucky.
People get hurt.
Good
right?
support. You've got good university support. You've got great partners. Your logos are spectacular. We've got 10 people that are supporting us, and then Olivia and I paid last year, and it's $8,000 to $10,000 just to get to Resolute, and then it's another $2,000 to $3,000 per person to get from Resolute, which is where we stage, to Tallarootee, Devon Island. And so, we're $15,000 out of our pockets, and we're all walking around, our pockets are turned inside out. We're like, this is fun, but once you're there, it's amazing. Amazing.
Last question.
Just a very simple softball. What did you eat when you were in Devon Island?
Oh yeah, well, we weren't conducting any nutrition studies, so we were just trying to eat as best as we could for morale mainly. We brought some of the Mountain House pre-made meals for the beginning and the end of the mission, just in case we weren't able to get the sort of kitchen up and running in time, and those were very nice. But actually, once we moved into cooking proper meals, it was so much better.
Yeah.
It had a huge impact on crew dynamics, firstly, because we would all help out. And we also had this bread maker, which was really the kind of...
It was the winner.
The cherry on top, really. We would use it almost on a daily basis, and was really fantastic.
That's a Zubrid thing. He's like, fresh bread every day. It's the smell, and it's da-da-da. And he's right. After our experience, I would agree. I made tortillas one day. Like, I love tortillas. Anything with flatbread, right? And Caleb made us pizza one day, like a real pizza. Yeah. So, to answer your question, tons of food, not a problem. That's it. Love you guys. Be safe, please, wherever you head from here.